Hello and welcome to this tutorial video where I'm going to use some JavaScript to deal with object pooling. So if you're interested in object pooling, this is how to do it. And so basically what I'm going to do is create particles using this method. And the reason why you might use it is to optimize, say, a game where you might have lots of projectiles flying around. You want to create those projectiles on the fly and do things in a more efficient way. So I'm going to do this from scratch, so you'll learn lots of other little things on the way, like looping, and maybe I'll try and use a for each loop, and iterating over different objects, object creation in the first place. Anyway, so I'm going to do this on CodePen so that you can do it, you can get started as quickly as I can. So I'll leave a link in the description to how you can get to this pen on CodePen. If you haven't seen the CodePen site before, it's a brilliant place that just hosts like little demos or even game simulations, ideas like this, where you can code right in the browser and it updates as you go along if you want it to. So I've got myself set up with a template, my P5 template, and what this is an empty JavaScript program. All I've got is a setup function and a draw loop. So that draw function just loops around and around and around, and the program will start here at setup. And all I've done so far is create a canvas 400 pixels by 400 and then give it a lovely background color. In the HTML, what I've got connected is the library that I'm using, and I'm using, there we are, this P5.js library. I'll put a link in the description also to how you can go to their website, and they've got lots of tutorials on how to get started. So if you wanted to do it locally on your computer and not go into CodePen, they'll give you all their tutorials and resources that you need. Also, it's a great reference for if you forget anything. I'll try and go on their reference site actually while I'm making this. So all you need to know is, in the HTML, I'm importing or connecting to the library that I need to use certain functions like create canvas and background. And these functions, the setup and the draw function, these are conventions of the P5 library. And it's a library that makes input, graphics, animation a lot easier for you when working with JavaScript. Right, I won't need the preload function. So let's make some particles. One way you could do this, let me just make my code a little bit bigger. There we go. I think you can read the font size. Might make it a bit bigger. There we go. Right. One thing we could do is just make a circle. So to do that in P5, you'd write ellipse, and then you give it an X location and a Y location. So let's say 200, 200, which is halfway through the screen. And then a radius or diameter. I think it takes a diameter, the ellipse function. So let's say 70. And once I've written that, yes, we got a circle. Brilliant. There we go. Easy as that. We could also do something like, let's do a very similar thing down here in the draw loop. So the setup function just works once. That's where the program begins. The draw function loops over and over again. So it's in Unity, this would be your update function. Or if you're talking about your game engine, it might be your game loop, or an animation thing that you're making. It would be the animation loop. So we could do the same thing. We could call the ellipse function. This time, let's use variables. Let's use the P5 constants, mouse, or what do you call them? Like P5 terms for the position of the mouse. And then again, we'll have, I don't know, a diameter of 42. This time, yes, each time that's going around the draw loop, we get a new circle drawn at the mouse position. So what if we wanted like animation to kind of happen, or the illusion of real movement? We could paint over the background again And let's use the same color. 200, 200, okay. There we go. So at the start of each frame, it repaints. So we're going to lose that first ellipse that we made, but we're going to repaint, and then we draw a circle at the mouse position. So now we get the illusion that we've like created a cursor. There we go. We could turn off the cursor in HTML. Something like cursor false or something, I don't know. Right, right. We want to create lots of kind of particles, and we could copy and paste ellipse over and over and over and over again to have lots of circles and things. But the point of programming, of coding, is that you can create like the recipe for an object, and then you can instantiate, that means like make or create, lots of that object from just programming its recipe. So to do this in JavaScript, using ES6 convention, the ES6 convention, you can write class, and we'll call it, what should we call it? It kind of looks like a moon, so we're going to make it look the same. So we want a moon, and then your curly brackets, and we've written a class now. We can now go and make lots of little moons if we want to, but we need to explain what variables it's going to have, what features, and what it can do. So first we write a constructor function. And what will happen is when we instantiate, when we create a new moon, this little constructor will be called, and you have to call it constructor. Okay, so when we create a new moon, we're going to give it a position and a size. I'm going to put R for radius, or maybe I'll put D for diameter, because the ellipse function, I believe, uses the diameter. Okay, so then we say this dot x equals x, this dot y equals y, and this dot diameter, I'm going to call it, or dia, equals d. Notice that these variable names could be anything. I could put this dot x position. It doesn't have to be the same as the parameter. This parameter is just a temporary variable up here that's just going to die, just be removed from memory as soon as the function has run. Okay, but I've just kept them the same so that I know what I'm talking about. Sometimes I put a little underscore here actually. I think Dan Schiffman used to do this. Right, you just put an underscore next to these variables so I know that they come from a parameter. Anyway, I'm getting distracted. Right, so this dot, what that means is this variable, or each of these variables, belongs to a particular object, which will make more sense as we create lots of objects. All you have to remember now is that when you use this dot, you are saying that this object, this moon, has the variables that you're describing here. It's kind of like a recipe. So we've got enough variables there, I think. Now, how do you write a function? You don't have to write the function keyword in a class. You just write the name of the function, just like we've done here. A constructor, remember, is a constructor function. So I usually call my my like show or display function render. So the constructor function is the only function that you have to write. You have to have a constructor, and you must call it constructor. But these functions are personal to you. You can call them whatever you like, and they can do whatever you like, and you don't need them. So they're optional. So render, all we're going to do, let's copy this code. There we go. And instead of mouse x, mouse y, we're going to say this x position. So this object's x position and its y position, and the diameter will be this dot d. There we go. Right, let's save that. And oh, I haven't titled this. What am I going to call it? This is like, oh, what are we doing? We are making a pool pooling. We're pooling. What do you call that? Object pooling. Object pooling tutorial number 1. Okay, save that. Right. So now that we've got a class, an object's kind of like recipe, we can instantiate lots of them. So let's have a new one made every time we drag our finger or drag the mouse on the screen. So P5 has got another handy like event function, event call function. Let's say mouse dragged. I believe if you just drag your finger across the screen, P5 will report that as a mouse drag. So if you're using a touch screen, it automatically translates for you that into a mouse drag. So we're going to say new moon, and then remember, when we construct it now, we've got to give it an X, a Y, and a D. So we could create it where we're dragging. That makes sense. So let's say mouse X, mouse Y, and the diameter 42, was it? 42. Okay, so let's see what happens at the moment. So I'm dragging my mouse, nothing's appearing. Why is nothing appearing? Nothing's appearing because we're not actually asking that moon to be rendered, to be drawn. So we would do that in the draw loop. So we've got to get hold of the moon that we've just made. We've just made a new moon, so we can't like get hold of it. It's not called moon because, so I just tried to highlight that. It's not called moon because that's the name of the object of the class, which is just an idea. It's just like a virtual object ready to be instantiated, to be made. So we've got to call each individual one that we make a name. Let's use an array to do that, because if we make lots of them, it makes sense to have an array, which is just a name and an index. So it's a bit like a train with lots of carriages in. So we just got a name for the train, and then each carriage has got a number, and we start with 0, 1, 2, 3, 4. So if we wanted to grab the fourth moon that we made, we'd say, let's say we called out, what are we going to call our, oh, we call them moons, I guess. Let moons equal open square brackets. So that's how you create an array. You write equals open square brackets, and JavaScript now knows that this is an array. And by convention, you would pluralize the name. So instead of moon, I've called this moons. So by convention, you know that this is not just an ordinary variable, but an array. So if we wanted to pick the fourth moon, we can now say moons, square brackets, now not 4, because we start counting with 0 in arrays, so it'll be 1 less than that, it'll be 3, that'll be the fourth moon. 0, 1, 2, 3, there we go. We've got it right. Okay, so but not really, that was just hypothetical. So here we want to say something like moons, and then we need like a number, and that needs to go up every time we create a new one. So you might think we have to create a variable to keep a track of what index we need, but we don't. Because this is such a common thing when dealing with arrays, they have their own function to push on, or like almost like dropping in a new object into a new carriage. So what we actually write is the name of the array, moons, dot, and now we can access the functions that you get for free when you make an array. Push, and then in parentheses you put in the object that you want to add to the array. So we could add the object 23. That would be like an integer or a float. I don't know how JavaScript would receive that, but we want to drop in a new moon, because when we call new, use the new keyword, JavaScript knows to go and look through the classes that we've written and look for one with that name. And by convention, I don't think I mentioned this, when you write a class, your object by convention we start it with a capital letter, so you know that it's an object. So we've asked for a new moon. So that will return, when we write new moon with the various arguments, it will return a new moon. So that new moon will be plopped into the array. And we don't have to keep track of how many we've made. This push function will do that. It will get this object and it will find the end of the array and put it there. Right, so we can now make lots and lots of moons. We're storing them in an array, and now it's very easy to draw them all. We can now say for, now we're going to make a temporary variable, let's call it little m for moons, for m of moons. And what that means is, for each whatever object we've got there of this array in moons, do the following thing. So it's a bit like a for loop, going over every single, looping over and over and over again, where we could increment an index. So we could go over moon 0, then moon 1, then moon 2, and we could render them all. It's a bit like that, but all you have to write is for each m of your array name. And I've just chosen m. You can choose whatever you like, because it reminds me of moons, so it makes some kind of sense. So that temporary variable is going to store each object in this array. So if I write render, that's now going to go over all the objects and render them. So here we go. So if I now drag the mouse, we should get a new moon created. And we don't. Nothing is happening. Well done you if you know why not. I don't know why. I've made some kind of bug. Written some kind of bug. For m of moons. I got mixed up, didn't I? I was thinking about the class name. I was just talking about that. Whereas the array name is lowercase. Okay. But bless JavaScript for not exploding. It just tried to run it anyway. No warning messages. Right. Oh, it's working. It's actually working. So, we've done it. We've done the first step of what we're after. We've got an array of lots and lots and lots of moons. I wonder if I can use the console on here to find out how many I've got. Can I write moons length? That should return the length. Right, we've got 567 moons on there. Brilliant. So it's not just the same moon kind of smeared around. We've got lots of them, which means we can do interesting things. We could add some gravity to those moons. Let's just go and let's go and do that. Or should I? Should I make gravity? No, I should stick to the plan of this video. So I'm supposed to be pooling these objects. So, what that means is, at the start of our program, we want to create lots of moons, let's say 600 moons, and then we kind of want to hide them. We want to make them inactive. So we can't see them, and they don't take up any computation. They're just invisible, and nothing's happening to them. And they're certainly not being drawn, which is the same as invisible. So instead of creating a new object and then pushing it onto an array every time we want a new object, object pooling just switches on a moon. That's it, just switches on an object. And you see that's a lot quicker, a lot more efficient than having to create the object and put it onto the array and now keep track of it. You've already, at the beginning of your program, got all of those moons and kind of hidden them somehow. Right, so we could do that. In setup, we don't need to draw this circle anymore. And we don't actually need to draw the background, do we? Because that's happening every time in the draw loop. We do need to create a canvas, 400, 400. Let's create a lot of moons. So we will have a for loop this time. So for let I equals 0, I is less than, how many should we have? Well, I'll just call that amount. Well, the amount is less than that. I plus plus. There we go. That's how to write a for loop. I don't think I'll describe that. You can kind of copy it. So that will just go around how many times I put into this variable here. So let amount equal equal, and let's make 600 of them, 600 moons, and I'm going to put them into an array. We need to be able to go and find those moons again, so I can't just create them. I need to store them in moons. So the moons array. So let's do that now. So I'm saying get hold of the array and then push a new moon. Now I don't want to say where the mouse is, because that's going to be 0, 0. So I think there are 600 moons up at the top here. In 2D graphics, 0, 0 will be top left as you look at the screen. So we could do two things. We could make sure they're drawn off screen, in which case they're all being drawn, but it will be off screen, so they're kind of invisible, they're not interacting with anything. Or we could give each object an active, inactive Boolean variable. So I think I'm going to do that. And of course I can still make new moons. So object pooling, what I really want to do is when I'm pressing the mouse, I want to go and grab one of those invisible moons, make it visible, and make it appear there. That would be a lot quicker. We didn't have any like efficiency problems with this. Well, maybe there's a bit of lag. Maybe the mouse is getting ahead of the moons a little bit. I don't know if that'll be affected if we do object pooling. Anyway, let's go and do this. So we will say this active equals false. So when it's first created, by definition, by default, our object will be false. Now in our render function, we'll say if you are not active, remember I've got to write this dot active, not just active, because active doesn't exist as a free floating variable on its own. It's a property that applies to this object. So I've got to write this active. Maybe you've never seen the exclamation mark before. That means exactly the same thing as equals false. You also might be wondering, why have I written 3 equals? I could just write 2. Basically, 3 is quicker as long as this variable is of the same type as this variable, as the false variable. And I know that's true because this active I've declared as false. So it's going to be a Boolean, a true or false. And false is a Boolean, definitely. So JavaScript won't have any problem there. If I put 2 equals, it will still work. It'll be slightly slower. It probably won't make a difference in this application. But if you just put 2 equal signs, you're saying, JavaScript, I don't know if these 2 variables will be of the same type. So go and check that for me. Go and do that, and then compare them. Once you've got the meaning the same, having being the same type, then you can compare them. So that little check takes a little time, a little bit of work. So you should probably do that in a lot of the time when you're not sure, you know, if you're going to get a float versus an integer and so on. But if you know, like me, I've defined it there. It's definitely a Boolean. I'm definitely dealing a Boolean with a Boolean. I'll put 3 equals. It'll be slightly faster. It won't make any difference. Anyway, so if I say, or I could just, I want to go to my original one. What means exactly the same. I'm going to say, if this is not active, then return. There we go. So if I try to draw a moon that's not active, it won't draw it. It'll just get out of that. It'll get out of there. Get out of that function. And there we go. Our moons at the top, our 600 moons are no longer being drawn. And I imagine that's a lot faster, running a lot faster now. Okay. So we've done the first bit of object pooling. We've created a pool of objects. We've made 600. with this for loop in the setup function, and our object itself has an active boolean, which like a little switch. We can say it's true or false. If it's not active, if it's false, then it's not drawn. That's brilliant. So now what we want to do is when we drag the mouse, we don't want to make a new moon. No. We want to set a moon active. So we've got to choose one of these moons. We've got to say moons and then some number in here dot active equals true, and then it will appear. So also, what do we want to do? When we've created it, we then want it to appear where the mouse is. We could I'm just saying 0 for now, just as a placeholder. We could say it's x equals mouse x and moons 0. Oh, oh dear. Moons 0 dot y equals mouse. Oh dear, mouse y. There we are. I need a new line there. Okay, so now if I click or drag the mouse, yes. Now what's happening here? I'm not getting a new object each time. I'm just grabbing moon 0 and I'm activating it. Okay, but that means we've got 599 other moons doing nothing there. And I've not got the same behavior as earlier on. Earlier on in the program, I could drag and get a load of moons there. But I was creating more and more and more and more moons, and eventually it would grind to a halt. There wouldn't be enough memory in my computer. It would just get, it wouldn't be able to handle, my processor wouldn't be able to handle all of the moons. So 600 moons we could maybe deal with. Okay, so what we want to do, we want to have a little variable in here. We'll call it which. I think I can call it which. So we're asking which moon do I want to get hold of. So basically, if I've got hold of moon 0, I now want to go and get hold of moon 1, and so on, moon 2, 3, 4, 5, all the way up to 600. But once I get up to, or 599, because we started counting at 0, if that which variable gets to 600, then I want to put it back to 0 again. Or I want to say that you can't make any more moons. But what would be interesting is if we make it get to 600, then revert it back to 0, and that would mean it would suck up the last moon, the oldest moon made, i.e. the first one we put down, moon 0, and it would kind of be like a snake following it. Right, let's see if we can do that. So first we need this variable. We need let which equals 0. So we'll start with moon 0. There we go. And then once we've dragged our mouse or used a touchscreen and we've placed a moon down, we then want the next time that happens which to go to the next moon in the array, which we've already created. So we're just switching on a new moon. Well, that sounds kind of poetic. We're switching on a new moon. So we want to say which plus plus. There we go. If you've not seen that before, that means which equals which plus 1. Can you think of another way to write it? I think you can write which plus equals 1. So these 3 lines do exactly the same thing. Which plus equals means which equals which plus whatever number you put here. So that will go up by 2. Right. Stop playing around. There we go. So which plus plus. We'll just get bigger and bigger. So now, if I save, yes, I can get 600 moons. Now, I should be able to keep going for a while, but then it should stop because which will get too high. Ah, there we go. A good old JavaScript. I don't think it's crashed. It just which now must equal 612 or something. And we haven't created 612 moons. We haven't loaded that into memory yet, so it's not doing anything. So what we now need to do is say if which is greater than, now we could put a number in here. We worked out if it's greater than 599, but when dealing with arrays you want to be very careful and kind of dynamic, so it would be better to write moons, that's the array name, and just like we could write push, i.e. we could use some array functions, we can use dot length, which will return us the length of the array. Now, we went round this loop 600 times. That means the length of the array will be 600. But we've got to be careful. If we're going to use which as our index, then we want one less because we started at 0. So there we go. So if which has got larger than our array, then which equals 0 again. So now we could kind of go on forever. And we can change our amount because this little algorithm will now dynamically change with how many we're creating. So let's just say 9. 9's my favorite number. There we go. Save. Right. Creating moons. Oh, we're just creating 9 little moons. We need a longer tail. 99? Oh, brilliant. And now our tail is kind of catching up with us. It's kind of like a snake. Woo. There we go. So once it reaches its maximum, it sucks up the end of the tail and places that where the mouse is. That's beautiful. So now, there we go. Now that's very efficient. You're controlling exactly how many objects you need, and you're switching them on and off when we need them. And so that's what you might do if in your game you're using projectiles like bullets or bombs and things, and let's say your player could only ever fire 17. Like, if they fired as fast as they could, you'd only ever see 17 on the screen. Well, in that case, instead of creating a new object each time and then having to destroy that object each time, you could just load, let's be safe, not 18, 17, let's say 40, 20 or 40 of these bombs or whatever you're making, and then just make them active and inactive. So you're not having to create them while your game loop is running, you're not having to destroy them and then remake them. It'll be a lot more efficient. So there you go. That's how object pooling works. I hope that was helpful. We also did this nice for each kind of loop. It's kind of a for each loop, which is it's very nice, isn't it? It's very succinct. It kind of makes sense. Whereas a for loop, we could iterate over all of the objects. I usually do that. It's a lot longer to kind of type out. Although, for efficiency, I believe for loops are faster. I don't know whether that will change, depending on certain things. But there you go. Was that everything I said in my introduction that I was going to do? I think so. Anyway, so that was some basic stuff with arrays, etc., etc., etc. Put down any comments for any future video you might want, or anything here that maybe gave you an idea of what you wanted to do, and I'll be happy to try and do that. And indeed, if you make anything on CodePen, put a link in the comments and I'll go and have a look. That'll be brilliant. Thank you very much. See you next time.